Okay, in this video I'm going to go through the notes over conditional probability, and we are going to explore the question, how does the eye color of your parents influence your own? And so we're going to fill out this chart here, and to find our totals all we have to do is add the two from the column. So if I want to know the total number of babies with brown eyes, I just add 754 and 508, and that should be pretty easy to do for 1262. And then the total number of babies that have blue or green eyes, we would add 245 plus 493 for 738, and just filling in our table here. We also want to know the total number of parents that have both, where both parents have brown eyes. So we do 745 plus 245, and that gives us, 754 plus 245, and that gives us 999. And then we want to add up the total number of parents that have, where in this case where one parent has brown eyes but the other does not, and that is 508 plus 493. So 1001. And then so the total number of, this is data collected on the eye color of infants, so the total number of infants that were studied here was 2,000. If you add these two totals and you add these two totals, you will get the same value there. So now that we've filled in our totals, we can start answering questions about probability. What is the probability that a baby will have blue or green eyes? So we take the total. We are talking about 2,000 babies altogether. What is the probability that a baby will have blue or green eyes? Well, we go to the right column and we write down the right number. So 738 out of 2,000 babies will have blue or green eyes. And of course that is a simple calculation in the calculator. So about, I'm just gonna, well no, it is exactly, let's say 36.9%. And then how about for brown eyes? Again, we take the total of 2,000. And how many babies have brown eyes? 1,262. So we can calculate that in the calculator. 1262 divided by 2,000. But also that would be the same as the complement. If I had just done 1 minus this value, I would have gotten the same thing. So that is 63.1%. Okay. Now we're going to do our first conditional probability. What is the probability that a baby will have brown eyes given, and this is your key word for conditional probability, given that both of their parents have brown eyes? So a typo there. So we're limiting ourselves to this column only. This case where both parents have brown eyes. So our denominator now is only 999. And the thing that we're interested in, the probability that a baby will have brown eyes under these circumstances. So if we limit ourselves to just the cases where both parents have brown eyes, we see that babies are much more likely to have brown eyes. And we can do 754 divided by 999, and we get nearly 75.5%. I'll use an approximately equal sign there. About 75.5%. So compare that to the total population that has brown eyes, is only 36%, or nearly 37%. But if we know we're only talking about babies where their parents both had brown eyes, then the probability of brown eyes shoots up a lot, all the way up to 75%. And of course we can ask a similar question. What is the probability that both of a baby's parents will have brown eyes given, so there's our key word for conditional probability, that the baby has blue or green eyes? So we go to the case where the baby has blue or green eyes, and we limit ourselves to this column only. So our denominator now is only 738. And what do we want to know? The probability that both baby's parents have brown eyes under these circumstances, only 245 out of 738. 245 out of 738 is approximately 33.2%. And perhaps maybe even a little bit more interesting, even though it's not written here. If I limited myself here to this column, and I was only looking at babies that have both brown eyes, and I wanted to find out what the likelihood that both of their parents had brown eyes, that would not be the same as when I limited myself to both parents having brown eyes and looking for babies' eyes. So the data often sort of plays tricks on us. It's very common to get results that you do not expect. We've got 59.7%. So the probability that a baby had brown eyes, given that both the parents had brown eyes, is different than the probability that both the parents have brown eyes, given that the baby had brown eyes. Okay, so moving on. The question of eye color is an example of conditional probability. We are restricting ourselves to considering only part of the whole in order to get a better sense of how one variable influences another. Venn diagrams are another good way to do this. We can see that inside the box there are a total of 45 students that have been surveyed. 15 of these students take neither chemistry nor biology. 8 take only chemistry. So these 8 are in this section of the circle. And 13 take only biology. So they're in this circle over here. But then we have this crossover section in the middle here. 9 students take both chemistry and biology. So what is the probability that a student takes chemistry? Well, this is out of the whole. How many students take chemistry out of the whole? Well, there's the 8 that take only chemistry, plus the 9 that take both chemistry and biology. So that's 8 plus 9 as our numerator, and of course that is 17 over 45. And then the calculator will produce the correct answer there. So it's about 37.7% that take chemistry out of the whole. What about the probability that a student takes chemistry but not biology? So again, we're still interested in the whole, but this time we're only interested in the 8 students that take chemistry, and we aren't interested in these 9 that take both chemistry and biology, so we say 8 over 45, and then that helps us get our probability with the calculator, about 17.7%. Now, these two questions are conditional probabilities because we're going to limit the part of the graph that we look at. What is the probability that a student takes chemistry given, keyword for conditional probability, that he takes biology? So we're limiting ourselves only to students that take biology. Just like in the previous section, we limited ourselves only to babies where both parents had brown eyes, or only to situations where the baby had blue or green eyes. We're limiting how much we're talking about, not looking at the total, only looking at the students who take biology. And the students that take biology are the 9 that take both biology and chemistry, plus the 13 that take only biology. What is a probability that a student takes chemistry? Well, there are 8 students. No, wait a minute. Because we're only considering this circle here. this 9 and this 13. Of that 9 plus 13, only 9 take chemistry, and they are the 9 that take both chemistry and biology. We aren't considering these 8 that take only chemistry because we've limited our sample space to just what's inside of this circle. Okay, and of course you can do the math there, 9 over 22, and the calculator will produce a nice percentage, about 41%. And then we'll just do a different conditional probability here. What is a probability that a student takes biology? So our numerator is going to have something to do with biology, given that she does not take chemistry. So we're talking about everybody that does not take chemistry. So that is everybody outside of the chemistry circle. And how many students are outside the chemistry circle? There's the 13 that take only biology, and there's the 15 that take neither biology nor chemistry. Of that restricted sample space, what is the probability that a student takes biology? How many biology students are in that group that is outside of this circle? 13. And then you would simplify the fraction, 13 over 28, and you would get your percentage at roughly 46.4%. Okay. So your job now is to use these notes and to go do the practice problems on Kia, where there's one of these tables to fill out and some questions about probability and conditional probability. And then there's another Venn diagram practice problem with conditional probability questions.